Hi all, welcome to new class. Today's class is the continuation of the conversion of flip-flops. So if you didn't watch the previous classes, please go through it. The link will be given in the description box. Let us study about the conversion of JK flip-flop to D flip-flop. So here the required flip-flop is D flip-flop. Then that input is given to a combinational circuit and whose outputs are given to the actual flip-flop. Here the actual flip-flop is JK flip-flop and whose output will be the required flip-flop's output. Now we have to write the truth table with D input, then Qn, which is the present state, Qn plus 1, the next state to be obtained, then Jk inputs. So here D input, then outputs. Outputs are Qn and Qn plus 1, then Jk inputs, that is J and K. So with D input and Qn, the possible combinations are 4, 0, 0, 0, 1, 1, 0 and 1, 1. Now we have to find the next state to be obtained with this D input. While applying 0 to D input, the output is 0. Here also 0, then output will be 0. While applying 1 to D input, the output will be 1. Here also while applying 1, the output will be 1. Now we have to find the JK input for these outputs. So this is the next state to be obtained. To obtain 0 in JK, so the JK inputs should be 0 and 1. And here while considering these two outputs, no change. That means no change condition in JK input is 0, 0. So we get 0 don't care. 0 and don't care. Don't care means it may be 0 and 1. Then here this is 0. To obtain 0 in JK input will be 0 and 1. And here these outputs are changing. So toggling condition in JK means the JK inputs are 1 and 1. That is we get a don't care 1. Don't care 1. Next is 1. To obtain 1, JK inputs are 1 and 0. And here also the output is changing, that is toggling condition 1, 1. That is 1 and don't care. Then here the output is 1. To obtain 1, 1, 0 is the input to the JK. And here no change. That is no change condition is 0, 0. That is we get a don't care 0. That is don't care 0. Now we have to design JK using K-map. So here the variables are D and Qn, that is two variable K-map we have to draw with the variables D and Qn. So we have to find J and K in terms of D and Qn. Here 0 1 0 1 0 1 2 3. For J 0, then don't care, 1, don't care. So these two small squares we can combine, and that value is D. Next is for K. Again draw two variable K map with variables D and Qn. Here 0 1 0 1 0 1 2 3. For K the values are don't care, 1, don't care, then 0. So here these two small squares we can combine, and this is for K, and its value is D bar. Now we can draw the logic diagram. So here the actual flip-flop is JK. So draw the actual flip-flop. Draw the actual flip-flop JK. Qn and Qn bar are the outputs. And here J equal to D. So here D is the required flip-flop input. So D input. Then J equal to D. J equal to D. Next is K equal to D bar. That is here one inverter or NOT gate to K. So this is the logic diagram for the JK flip-flop to D flip-flop conversion. Next is D flip-flop to JK flip-flop conversion. So here the required flip-flop is JK flip-flop. Then there will be a combinational circuit and whose outputs are given to the actual flip-flop. Here it is D. And whose output will be the required flip-flop's output. Now we can draw the truth table. Truth table with JK input, then Qn plus 1 and D. So JK input, truth table we can write JK inputs J and K, then outputs Qn and Qn plus 1, where Qn is the present state and Qn plus 1 is the next state to be obtained. Then D input. With J, K and Qn, the possible combinations are 8. 0, 0, 0, 0, 0, 1, then 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. So for these JK inputs, the next state to be obtained we have to calculate. For JK input 0, 0, the output will be no change. That is, this 0 will be here. Here also 0, 0, the output will be no change. That is 1. And for JK inputs 0 and 1, the output will be 0. Here also 0, 1, the output will be 0. It will not depend upon the present state. Here 1, 0 to JK input means the output will be 1. Here also 1, 0, the output will be 1. And here 1, 1. 1, 1 to JK input means the output toggles. That is 0 changes to 1 here. Here also 1, 1. So toggle means 1 changes to 0 here. Now we have to calculate the D input to the actual flip-flop. To obtain 0, the D input will be 0. To obtain 1, the D input will be 1. To obtain 0, 0, 0, here 0. To obtain 1, the D input will be 1. To obtain the output 1, D input will be 1. To obtain 1, D input will be 1. And to obtain 0, the D input will be 0. Now we have to design for this D, that is D in terms of J, K and Qn. So here there are 3 variables. So a 3 variable K map we have to draw. So draw a 3 variable K map with variables J, K, Qn. 0, 0, 0, 1, 1, 1, 1, 0. Here 0 and 1. 0, 1, 2, 3, 4, 5, 6 and 7. And here 0, and this is for D. 0, then 1, 0, 0, then 1, 1, 1, 0. So here these two squares we can combine, and also these two squares we can wrap together. So for these two squares, the expression for D is this one, that is K bar into Qn. And for these two squares, the expression is J, and here the constant variable is Qn bar. It is plus J Qn bar. That is D is equal to K bar Qn plus J Qn bar. Now we can draw the logic diagram. So the actual flip-flop is D. So first of all draw the D flip-flop. So this is D, then clock, then Qn and Qn bar are the outputs. And D is equal to K bar Qn plus J Qn bar. So J and K are the required flip-flop inputs. So here J into Qn bar. So one AND gate is there. J into Qn bar. So Qn bar is this one. So this is J into Qn bar. Next is K bar into Qn. So K bar means one NOT gate here. Then AND gate. K bar into Qn. Qn is this one. So K bar into Qn, then plus. So one OR gate. One OR gate is there and is given to D. So this is the logic diagram for D flip-flop to JK flip-flop conversion. So thank you for watching the class. If you like the classes, please like, share with your friends and subscribe my channel.